Hello viewers, welcome to this video. Right, in this video we are going to be looking at Rancher. Rancher is a tool which you can use to manage multiple Kubernetes clusters. So I've done a video on Rancher a while ago. I think it's nearly a year ago. So if I search in YouTube for Rancher Kubernetes, so that one here, set up Rancher for Kubernetes Kube 18, so which was done 1 year ago. So I'm going to be doing the same thing now. I'm going to be revisiting Rancher. How is it looking right now? But the focus of this video is to use Rancher to monitor your Kubernetes cluster. So things like nodes, pods, containers, how much CPU they use, how much memory they use, and so on. So I'm going to be showing you how to deploy Rancher first as a Docker container, not inside the Kubernetes cluster, but outside the Kubernetes cluster. You can also deploy Rancher inside your Kubernetes cluster, but I would like to keep it external. So on my host machine, I'm going to run a Rancher container, and I've also got a Kubernetes cluster running on my host machine, which I'm going to import into Rancher so that I can start managing my Kubernetes cluster from Rancher. And we'll be exploring the monitoring option that Rancher provides. So we can monitor our Kubernetes cluster using Prometheus, Grafana, and we will be looking at various stats from all those Kubernetes components. So that's what we will be looking at today. So to give you an idea of what I've got in my machine for this video, kubectl version -- short. So I've got Kubernetes version 1.17 running. kubectl get nodes, 1 master node, 2 worker nodes. It's my usual Kubernetes environment. So now I'm going to start a Docker container to run Rancher. So it's very similar to the video that I done here. So exactly the same step. If you followed my video, if you haven't watched the previous video, this one here, Kube 18, please go and watch that video. Okay, so the command to launch the Rancher container is this one. So docker run, I'm giving it a name, Rancher -d to run it in the background, and I'm mapping the port 80 and 443 inside the container to my local machine, and I'm also using a Docker volume for persistence, right? So the directory var lib rancher inside the container, so that's the directory that contains the Rancher data. So even if you stop this container and restart the container, your data will be persisted. So that's why I'm creating my Docker volume here. And I'm using Rancher tag version 2.3.5. If you want, you can use Rancher stable or Rancher latest. But I'm going to be using version 2.3.5 for this video. And in case if you're using Rancher and if you're following this video at a later time, and if you're using Rancher latest, things might have changed a little bit. So I'm going to point you to version 2.3.5. So please use this version 2.3.5 or feel free to use the latest version. But if you've got any problems or any issues, or if anything has changed from what I'm showing in this video, it's probably that you might be using a different tag. So if I need to help you, I need to know what version of Rancher you are running so that I can recreate it in my environment. Okay, so that's the command to start the Rancher container, docker ps. So that's running on port 80 and 443. So if I hit the port 80 on my local machine, it's going to redirect me to port 443. Alright, so docker logs Rancher. That's running fine. So back in the browser, let's go to localhost. If you just type in localhost http, it's going to take you to the https site. And because we are running Rancher as a Docker container, we haven't used any custom certificates, so we are using the default self-signed certificate. That's why you're seeing this warning. That's not a problem. I'm going to hit advanced, proceed to localhost. Okay, so I'm just setting up a password, just some random password, and the next bit is the Rancher server URL. So I can't be using localhost. although it's running in localhost, my worker nodes, because I'm going to import Kubernetes cluster into this rancher, and the Kubernetes worker nodes needs to be able to talk to this rancher using this URL that I'm going to set now. So if I just leave it as localhost, the worker nodes, if it tries to connect to the local host, it won't work. So I need to put in the IP address of my host machine. So the IP address is 192.168.1.81. Save the URL. Okay, so there you go. That's the rancher dashboard. We haven't got any clusters yet, so the first thing we're gonna do is we're going to add a new cluster. So we're not going to create any new cluster, we are going to import an existing cluster. So this option here, import an existing cluster, give it a name, the name for your cluster, whatever you want it, click create, and now we're going to be running this command in our Kubernetes cluster in order for Rancher to import this cluster. So Rancher will be deploying some resources which we will see in a minute, so that it can start managing your Kubernetes cluster. So there are two commands. So this one is the first command, but we are going to be using this command here because we are running Rancher with an self-signed SSL certificate. So for that, we are going to copy this command and paste it in our terminal. And it has created these resources: a deployment, a daemon set, cluster role, role binding, service account, secret, namespace. So it has created a namespace called cattle system. So if I do watch kubectl -n cattle system get all. Okay, so it's creating the containers at the moment. So we can see there are 3 node agents deployed as a daemon set, because we've got 3 nodes in our cluster, a master node and 2 worker nodes. A node agent needs to be running on all of those nodes. So that's deployed as a daemon set, and we also have a cluster agent that's deployed as a deployment. So one of them is running. And back here, if you click done, your cluster is in the pending state. Very soon it will be in the active state. We are just waiting for the other containers to run. So I'm going to pause the video here. It only takes about 30 seconds to a minute. Alright, so all the containers are running fine, and back in the web browser, if you see your cluster just me is active, so I can click on this cluster and everything is looking fine. So you can go ahead and look at the nodes, storage, namespaces. So we've got the cattle system namespace, and if I go to the system, so there we go, we have the cattle system namespace with a deployment and a daemon set. Everything is looking fine. So now we are going to explore the monitoring capabilities from Rancher. So we've got our Kubernetes cluster, we've got Rancher running externally, we've imported our Kubernetes cluster into Rancher, and now we've got our Kubernetes cluster here. If I go to global, so we've got one cluster. Our Rancher is managing one cluster at the moment, and it has found our Kubernetes version is 1.17.3 with 3 nodes with some CPU and RAM memory stats. Okay, so now we are going to add monitoring. We are going to enable monitoring. It's going to be easy. If you're using Rancher, it's very easy to enable monitoring, and you have to be in the top level cluster. If you're in any of the namespace, you won't be able to enable monitoring. So make sure, because I'm in the default namespace now, you can see the default here, or if I go to system, you can see just me and system here. So you need to be on the top level cluster. So go back to the dashboard, Rancher dashboard, click on your cluster, make sure you don't see any namespaces here. Just me is active, but we have not selected default or system. So at the top level, I'm going to click on the tools, and we have monitoring here. So that's where you enable monitoring. So when you enable monitoring, it's going to deploy Prometheus, it's going to deploy some node exporters, it's going to deploy Grafana for visualization, and so on. Okay, so we've got some configurations here. Data retention, so how long you need to retain your metrics and so on. So at the moment it's set to 12 hours. You can change it whatever you want. Enable node exporter, set that to true. By default it's set to true so that it can collect metrics from your worker nodes. Enable persistent storage for Prometheus. If you've got dynamic volume provisioning enabled, you can set this to true, and then you can set how much space you want for Prometheus and so on, and you can select the storage class. Because I haven't got any dynamic volume provisioning, I'm going to set this to false. This is just for demonstration purpose, and if you kill the Prometheus container and when it restarts, it won't have the data back because we haven't enabled persistent storage. So just bear that in mind. And at the top here, there's a simple information here that says, when enable monitoring, you need to ensure your worker nodes and Prometheus pod have enough resources, because here we are specifying the reservation. So 750 milli CPUs, that's the reservation. So unless your worker node doesn't have 750 millicore of CPU, your Prometheus pod won't be running. So that's the reservation, and it can use up to 1 CPU. Similarly for memory, it needs at least 750 megabytes of memory on your worker nodes to start with, and it can use up to 1 gig or 1000 megabytes of memory. Similarly, node exporter, we are setting some CPU limits, memory limit, and memory limit for Prometheus operator, node exporter host port, and so on. Okay, so enable persistent storage for Grafana. Again, I haven't got dynamic volume provisioning. If you've got dynamic volume provisioning setup, enable the persistent storage. Okay, I think that's all we need. And if I click enable, cluster level monitoring is enabled. That's it. Saved. And now we can go back to the cluster, and if I look at events here, you can see there's a new namespace called Cattle Prometheus, and it's pulling the container at the moment, which is Kube state metrics, node exporter, Prometheus, and so on. Okay, let's go to the system project, and as you can see here, we've got the Cattle Prometheus namespace, and it's deploying few resources, and we have to wait for it. So we've got Kube state cluster, we've got node exporter, we've got Grafana, we've got Prometheus operator, which is running at the moment, and node exporter is going to be a daemon set because we want it to be running on all the worker nodes we've got. So that's deployed as a daemon set. That's a deployment, and these two are stateful set. Okay, so that's what we've got. And back in the terminal, if I look at kubectl get namespace, so that's the new namespace that got created when we enabled monitoring. Let's see what resources we've got in that namespace. kubectl -n cattle Prometheus get all. Okay, so we have lots of services. We have a daemon set for node exporter, we have few deployments, and we have a stateful set. Okay, so if I run the command again, so we've got 4 or 5 running for Prometheus, and this one, Kube state cluster monitoring, is not in the ready state. We have to wait for a while, and then we will enable Grafana access. So Grafana is the way we visualize our cluster. So we've got Prometheus running, we've got node exporters running. Prometheus is going to scrape all the metrics from the node exporters, and through Grafana we can visualize our cluster. So that's Kubernetes monitoring. All right. Okay, I'm going to run the command again to see the status of our pods. As you can see here, all the pods are running fine now. So our monitoring is completely set up. We can now log into the Grafana dashboard. But before that, where is our Grafana running and how do we access Grafana? So if you look at the services in the Cattle Prometheus namespace, the service here, access Grafana, is the service through which we are going to access Grafana. But at the moment, it's exposed as cluster IP, which means it's accessible only within the cluster. So we need to change the service so that we can access it from outside the cluster. All right, so I'm going to edit this service, kubectl -n cattle Prometheus edit service access Grafana. So I'm going to change the type from cluster IP to node port. If you've got load balancer, just use load balancer. If you're on bare metal and if you want load balancer, you can install or deploy Metal LB, which is a load balancing solution for bare metals. But I'm going to keep it simple. I'm going to change the type of this service from cluster IP to node port, and I'm also going to specify the node port. If you don't specify, it's going to give you a random port, but I'm going to specify the node port as well so that I can easily remember. 32323. Save. That's done. kubectl -n cattle Prometheus get service. Okay, so our Grafana service is now running as node port, and we can access it from any of our worker nodes on the port 32323. Okay, let's try if that's working. I'm going to open up a new tab and I'm going to access one of my worker nodes. So kubectl get nodes -o wide. Okay, so I can access the IP address of one of my worker node, which is this one or this one. I've also added the IP address entries to my etc host file. If I do cat etc host, you can see I've added the DNS entries for my Kubernetes nodes so that I can access it by name instead of IP address. Okay, so kworker1 or kworker2 doesn't matter. 32323. Okay, it's not HTTPS, it's just HTTP kworker2 32323. And there we go, it's loading our Grafana dashboard. So that's a simple Grafana dashboard, but when you enabled monitoring from Rancher, it has deployed you with some default dashboards. So click on the home here, and there we see all the dashboards that we've got. So there are lots of dashboards, lots of graphics, lots of panels added to all these dashboards. Let's see all of them one by one. I'm not going to go through each one of them because there are loads of these, but I'm going to show you some important ones. So first I'm going to choose the cluster dashboard. So we have all these dashboards, and inside each of these there will be lots of panels. Okay, first I choose cluster, and as you can see here, so we got various metrics, CPU usage, memory usage, file system usage, and we've got nice little graphs here. Okay, so it says at the moment total core is 6 core because each of my Kubernetes nodes has 2 CPU attached to it. So in total we've got 6 cores for the entire cluster, and we've got 12 gig. I've allocated 4 gig for all my worker nodes, so it's like 12 gig for the entire cluster. And you can also view by specific nodes. So the moment we are seeing for the entire cluster, and if you change it to K master, you can see my master node has 2 CPU, 4 gig of memory, and then 200 gig of hard disk. And if I go to kworker1 again, 2 core, 4 gig memory, kworker2 similarly. And if you look at the memory usage, like 10%, CPU usage is 2%, and if I go to master, 5%, and memory usage is 24%. Okay, so what else do you see? So that's the total usage. Okay, and we've got all other panels here, so loads of information that you can monitor from your Kubernetes cluster. And the next one we're going to see is node, and are there any disk pressure, memory pressure, PID pressure, and so on, and the number of nodes we have got. So total is 3. If there are any nodes that are unavailable or so on. So that's node deployments. We've got 6 deployments and all the deployments are listed here. Jobs, do we have any jobs? We don't have any jobs. Pods. Okay, so 23 pods running. Containers, we've got 28 containers running. It has requested 3 CPU cores in total. Network IO pressure, it's, as you can see, I just started my Kubernetes cluster and enabled monitoring, and so if you leave it running for about an hour, you will see nice graphs for all the metrics. So it's just started sending metrics to Prometheus. Okay, so pods, CPU usage. So CPU usage based on each of the pods, pod wise CPU usage. And then system services CPU usage, I don't see anything here. Maybe if I leave it running for a while, I might see some graphs on it. Container CPU usage, similar to pod CPU usage, you've got container CPU usage. All process CPU usage, so we've got that here. And then we have pod memory usage. We have container memory usage. Okay, so that's the cluster dashboard. We looked at the cluster dashboard, so now we're going to look at the daemon set. Okay, so we've got the desired replicas, available replicas, daemon set, CPU usage, memory usage, replica status, and so on. And you can also view by namespace if you want to look at kube system namespace, and also daemon set, which daemon set you want to look, and so on. Okay, if I change that to kube proxy, you see all those. Cattle Prometheus. Okay, so that's daemon set. And then we have deployment. Again, you can filter by the namespace and the actual deployment. If I change that to Cattle Prometheus, Grafana cluster, so that's deployment monitoring. We've got Kubernetes components. I don't see any graphs for this. Ingress, API server request latency, controller manager, and so on. Okay, what else we've got? Nodes. Okay, so that's quite interesting. We've got loads of information. The CPU load, 1 minute load average is 114%, so CPU utilization is too high. System load 5 minute average. The number of CPU cores, RAM swap used, root file system load, uptime, it's been up for like 12 hours. CPU usage, memory usage, network traffic, disk space used, and so on. And you can filter by the worker node. So at the moment it's showing 167. I don't know what's 167. 167 is my K worker 2. 187 is K worker 1. 50 is the master node. So let's look at 50. Okay, you can see 24% memory usage, and if I select K worker 2, 16%. Okay, so I've got these nice graphs. So that's basic CPU, memory, and disk usage, and you've got loads of other things, basic CPU, memory, and disk info. And then we've got graph, we have info, and we can look at memory detail, meminfo. Okay, loads of information about nodes. So these are all coming from the node exporter. Memory detail VM stat, system details, context switches, system load, process, memory, fork, time synchronization, loads of information, loads and loads of information you've got. Disk detail, let's look at node exporter. Okay, so the node exporter is sending metrics to Prometheus. It's not actually sending metrics to Prometheus. Node exporters are exposing the metrics on port 9796 on all our worker nodes, and Prometheus is responsible for scraping the metrics. It goes and pulls the metrics from all these worker nodes on port 9796. Okay, so network, netstat, so we've got loads of information here. Okay, so we saw cluster daemon set deployment, Kubernetes component nodes. Now look at the pod. So basic information about the pod. You can filter by namespace. Let's look at cattle Prometheus, and if you want to look at any particular pod, just select that pod, and if that pod has multiple containers, you can also select a particular container and look at some stats metrics for that particular container. Okay, rancher components. So we've got 3 active nodes. I don't see any data for any other graphs or anything. Do we have any stateful set? Yes, we've got a stateful set here. Cool. Alright, so that's Grafana dashboard, and one additional thing is in Rancher you can see all this information inside Rancher itself, so you don't have to change the service. So like what we did, we changed the Grafana service from cluster IP to node port so that we can go to Grafana and then watch all these metrics. But you don't have to really do that, because in Rancher you can view all those information. So if I go to global and if I click on my cluster name, and you can see some difference in the graphics here. Previously it used to be different, but since we enabled monitoring, it shows some additional information, more information about our cluster. And now you might have noticed the difference. So we've got the Grafana icon here, and if you click on that icon, it's going to take you to the Grafana. So let's look at that. If I click on Grafana, it's taking me to the Grafana dashboard, and we can see it here. So you don't have to really change the service from cluster IP to node port. I just thought of showing you how you can do it if you want to do it. All right, so, and you can also see some nice graphs here itself without going to Grafana. So if I expand this cluster metrics, and you can see the graphs here: CPU utilization, load average, memory utilization, network disk utilization, and you can change the way it shows. At the moment it's showing for the past 1 hour. You can change it to past 5 minutes, past 24 hours, or you can set a custom thing from, I want it from August 2019 to today. Not enough data for graph because we just enabled it for the last 10 minutes. Okay, so similarly you can look at everything. You can see all those graphs built into Rancher, or if you want to see everything in one place, you can go to Grafana. Okay, cool. I think that's all I wanted to show you for this video. We already saw how to set up Rancher, how to import your existing cluster, but this follow-up video was just to show you how you can use the built-in monitoring. It's a lot easier to, if you want to do it yourself without Rancher, you will have to deploy Prometheus, you will have to deploy Grafana, you will have to deploy node exporters, and that's not it. Once you log into Grafana, you will have to define all your dashboards. So with Rancher, it makes our life a lot easier. So I just ran a Rancher container, imported my Kubernetes cluster, enabled monitoring, that's it. So now I've got access to my entire Kubernetes metrics. Alright, thank you so much for watching. Please give it a try, and if you've got any questions, let me know. I'll be happy to help. I will see you all in my next video. In my next video, I'm planning to show you an additional feature, which is logging. Okay, so we've looked at monitoring, and in the next video we can look at logging. Basically what it's going to do is it will set up fluentd as a daemon set on all your worker nodes, and then it will collect logs from all the pods and containers running on all those worker nodes, and it can send those logs to Elasticsearch, Splunk, Kafka, syslog, or another fluentd. So in my next video we will set up an Elasticsearch container externally, and then we will configure a Rancher to send all the logs to an external Elasticsearch, and then we can view all the details. Alright, so thank you so much for watching. I will see you all in my next video. Bye bye.